Okay, in this example, we want to be able to eliminate the parameter to find the Cartesian equation of the curve. We have x, which is equal to e to the t minus 1. We have y, which is equal to e to the power of 2t. Well, if we take a look at the first part here, which is x, okay, we have x, which is equal to e to the t minus 1. Now let's solve for e to the t. If we add 1 to both sides, then we know that x plus 1 is equal to e to the t. And now we can substitute this e to the t into y. But in order to do that, we need to look very closely. Y is equal to e to the 2t, which means this is the same thing as saying e to the t squared, because that 2t means that you're raising it to a power of 2. And now what we can do is we can substitute what we determined e to the t to be, which is x plus 1, in for that. So let's go ahead and do that. We end up with y, which is equal to x plus 1 squared. So we also know that the restriction here is that x must be greater than negative 1. So what that means is that we're going to have the right side of the parabola. So now let's sketch the curve and indicate with an arrow the direction in which the curve is traced as the parameter increases. So we know that x has to be greater than negative 1. So if we want to graph this, we can put in our equation x plus 1 squared, which is x plus 1 squared. Okay, and then we have a restriction, and that means that x has to be greater than negative 1. So we're going to put in braces x, and that's greater than negative 1. Okay, so what does that tell us? Well, you can see here that at negative 1, it is undefined because it's not included. So let's go ahead and copy and paste this graph. So here's our graph. Okay, and so remember here that we should have an open circle at this point here. Okay, and so since we're starting here at negative 1 and it's continuing here, that means our arrows should be going in that direction.